A single rock the size of your fist hides a magnetic force strong enough to snap a human finger bone if it got in the way. That's not science fiction. That's neodymium. And right now, deep inside American factories, that rock is being transformed into the most powerful, permanent magnets on Earth. Magnets that steer missiles, spin wind turbines, and quietly power the hard drive sitting in your laptop right now. Here's the twist nobody expects. This story doesn't start in a factory at all. It starts underground, in rare earth mines like Mountain Pass in California, one of the only significant rare earth mining operations in the United States. Workers and massive excavators pull ore containing neodymium out of the earth. But here's the catch. What comes out of the ground isn't magnetic at all. It's just dusty, unremarkable rock. Turning it into the strongest magnets on the planet takes a process so intense, so precise, that most people will never witness it firsthand. The ore gets crushed and processed to concentrate the rare earth content, separating neodymium from dozens of other elements bound up in the same rock. This separation stage is brutally difficult. Rare earth elements are chemically similar to each other, almost stubbornly so, which is exactly why so few countries have mastered doing it at scale. But here's where things get really interesting. Once purified, the neodymium is combined with iron and boron in an alloy and melted down in a vacuum induction furnace, heated past 1,000 degrees Celsius, hot enough to turn solid metal into a glowing liquid river. Inside that furnace, oxygen is the enemy. Even a tiny amount can ruin the magnetic properties. So the entire melt happens in a controlled vacuum, sealed away from the outside air like a spacecraft being assembled in a clean room. The molten alloy is rapidly cooled onto a spinning metal wheel, a process that solidifies it in seconds into thin, brittle flakes. What happens next might surprise you. Those flakes are then pulverized into a fine powder, far finer than flour, with particles measured in mere microns. This is the step most people never get to see. Technicians handling that powder inside inert gas chambers, because exposed to normal air, it can actually ignite. Now comes the real transformation. That magnetic powder is loaded into a press and placed inside a powerful magnetic field. This is critical because it aligns every microscopic particle in the exact same direction, like millions of compasses snapping into formation at once. Align them wrong, and the magnet's strength collapses. Align them right, and you're building something extraordinary. The pressed powder, still fragile as chalk, moves into a sintering furnace. Here it's heated again, fusing the particles into a single, dense, solid block. This is where raw material finally becomes something recognizably powerful. A solid magnet blank, dark gray, dense, and deceptively simple looking for something so strong. But strength alone isn't enough. The real magic happens here, in precision machining. These blanks are cut, ground, and shaped using diamond-coated tools and specialized grinding equipment, because standard cutting tools simply can't handle a material this hard and this magnetically aggressive. Two magnets at this stage can snap together with enough sudden force to shatter if handled carelessly, which is why experienced technicians handle them with extreme caution, using spacers and controlled techniques to prevent them from violently colliding. Once shaped, the magnets undergo a coating process, usually nickel, zinc, or epoxy, protecting them from corrosion. Since raw neodymium magnets are surprisingly vulnerable to rust, despite their incredible strength. Then comes final magnetization, where the finished piece is exposed to an intense magnetic pulse that activates its full power for the first time. Before this step, the block is only magnetically capable, not yet actually magnetized. After it, that unremarkable gray block becomes a magnet powerful enough to lift objects hundreds of times its own weight. Quality control is relentless. Engineers test magnetic strength, dimensional accuracy, and corrosion resistance, because a single flawed batch could compromise everything from an electric motor to a medical MRI machine. Every magnet is measured, verified, and sorted before it's cleared for use. Finally, the finished magnets are carefully packaged, often separated with spacers to prevent them from crushing together, and shipped out to industries that quietly depend on them every single day. Electric vehicle motors, wind turbines, robotics, defense systems, consumer electronics. All of it powered by a process most people will never see. Starting from a rock most people would walk right past. From a dusty chunk of ore pulled out of American soil to one of the most powerful, precisely engineered materials on the planet. This is manufacturing pushed to its absolute limit. Every furnace, every alignment field, every diamond-cut edge exists for one purpose: turning invisible atomic forces into something you can literally hold in your hand. If this journey from raw rock to raw power blew your mind, make sure to like this video, drop a comment telling me which step surprised you the most, and subscribe for more incredible factory tours and manufacturing documentaries you won't find anywhere else.